Hi everyone, this video is the lesson about the special properties of quadrilaterals. So that goes along with your blue notes. Okay, so we have this big chart and some of the stuff that we already learned from last lesson, but we're going to learn a lot more about the sides, angles, and diagonals of each of our quadrilaterals. So before we do that, let's name them all and fill in our picture what we know already. So this first one, we have two sets of parallel sides. So what is the most specific name we can call this one? Good, this is our parallelogram. Okay, and the definition of parallelogram is that it had two sets of parallel sides. Next, we would have our rectangle, and the definition of that is that it has four right angles. Next would come our rhombus with its four congruent sides. And then our square that has four congruent angles and four congruent sides. Okay, so then next we have one set of sides parallel. So our first one would be our regular trapezoid. And next we would have our more specific isosceles trapezoid. And so our last category is when we have no sides that are parallel. And that was our kite that had two sets of adjacent sides congruent. Okay, so let's talk about each one in detail and fill in what we can find from those. And by the way, all this stuff that we're filling in are theorems about these shapes. What we just talked about and filled in our picture so far was based on their definition. So now everything else is extra based on the theorems about the shapes. Okay, so let's talk about our parallelogram first. So, based on our definition, we knew that opposite sides were parallel. But there's a theorem that tells us that opposite sides are congruent. We have a theorem that tells us that opposite angles are congruent. So we have opposite sides congruent, opposite angles congruent, and then we know that our consecutive angles are supplementary. Okay? So opposite sides congruent, opposite angles congruent. And then consecutive angles are supplementary. So remember, consecutive means those are the angles that come one after another. So these two would be supplementary. Those two at the bottom would be supplementary. Those two on the left and the two on the top. Okay. So remember we talked about what diagonals were back in 6.1. So this tells us that our diagonals bisect each other. So those lines that go from corner to corner are going to cut each other in half. So that means that this piece here would be congruent to this one, and then on this one, we would have it congruent to that one. It doesn't mean that these two pieces are congruent to each other, it just means that these two, they bisect each other. Okay, good. So let's move on and talk about our rectangle. So since a rectangle is like a son or daughter of a parallelogram, everything that's true about a parallelogram is true about a rectangle. We just might have more specific things as well. So our opposite sides being parallel, that was part of the definition of a quadrilateral. Our opposite sides being congruent comes from our parallelogram theorem. All those angles being right is our definition of a rectangle. So the diagonals being bisected, property of parallelograms. But the one new one that we have here is that the diagonals are congruent. So not only do they cut each other in half, when we draw them, they're also the same size. So from this corner to that corner is the same as from that corner to that corner. And if you think about it, that makes a lot of sense because of the Pythagorean theorem. So all four of those pieces are the same for rectangles. Okay, so moving on. Next we have a rhombus. So opposite sides being parallel, that comes from the definition of a parallelogram, and a rhombus is a parallelogram. All sides congruent is the definition of a rhombus. Opposite angles congruent is one of the parallelogram theorems, as is consecutive angles being supplementary. The diagonals bisect because it's a parallelogram. So these last two are the special properties of the rhombus. So those diagonals are also perpendicular and they bisect those opposite angles. So let's take a look what that would look like. So here's our diagonals. So this told us that those diagonals were perpendicular. So that means that these are all right angles here. And it said that they bisect those opposite angles. So those are bisected and so are those. And since opposite angles are congruent, those four pieces that we made are congruent. And the same thing is true for the other ones. The diagonal cuts that angle in half, and that angle here is congruent to this angle here, so those four pieces are congruent to each other. Okay, so moving on to our square. Square is my favorite. So opposite sides parallel comes from the definition of parallelogram. All sides congruent comes from the definition of a rectangle. All angles are right because it is a rectangle. The diagonals bisect each other comes from a parallelogram. The diagonals are congruent comes from a rectangle. They're perpendicular because it's a rhombus, and they bisect the opposite angles because it's a rhombus. So the square is just made up of the properties of the three above it. So everything that's true about a parallelogram, rectangle, and a rhombus is also true about a square, since it kind of flows down that family tree that we drew last class, or last lesson. Okay, so let's take a look at our trapezoid. So our normal trapezoids are kind of boring. All they got is that those one set of sides are parallel. There's nothing else special about their angles or their diagonals. You could, if you wanted to, say that these two angles are supplementary and these two are supplementary, and that's because the parallel lines cut by a transversal, they're same side interior. So we would have known that from there. It's not a special property of trapezoids, it's a property because of the parallel lines. Okay, so when we get to our isosceles trapezoid, we have those opposite sides, or those one set being congruent. So one set of opposite sides parallel, which was the top and the bottom, and then we have the non-parallel sides congruent, and that's the definition of an isosceles trapezoid. So about the angles of them is that each set of base angles are congruent. So this angle is congruent to this side, and then those top ones are congruent. Again, these are supplementary, just like we talked about for the last one. So their diagonals are congruent as well. So across those two diagonals are congruent. But they do not bisect, they're not perpendicular. So all we got is that they're congruent. They don't bisect those angles either. Okay, so our last shape is our kite. So remember the definition of a kite was that it had two sets of non-adjacent sides congruent. Okay, we have one pair of opposite angles congruent. So that would be these ones that are in between. And then the diagonals are perpendicular. So when we draw on those diagonals, they make right angles. I actually have one more property about the angles, and that's that those diagonals that bisect those non-congruent angles, that diagonal bisects each here, but they're not congruent across. So the diagonal bisects the non-congruent angles. Okay, so if you had a hard time seeing all these tiny writing, I will scan this and put it on my website. But before I want us to highlight in each category what the definition was and what the theorems were. Okay, so, or let's just do the definitions. So the definition of a parallelogram was that opposite sides were parallel. Okay, so those other 4 things is theorems. So the definition of a rectangle is that all those sides are right. So these are because it's a parallelogram, and these 2 are special for the fact that it's a rectangle. Okay, so those are special rectangle properties. These were special parallelogram properties. These are because it's a parallelogram. So the definition of a rhombus is that all the sides are congruent. So those are because it's a parallelogram. These are special because it's a rhombus. The definition of the square is that it's a rectangle and a rhombus, so all sides congruent and all the angles are right. And then the other things are true because of it being the top 3. Okay. So the definition of a trapezoid, one set of opposite sides parallel. And that's all we got. Poor lonely trapezoid's got nothing special about it. So the definition of an isosceles trapezoid is that it has those non-parallel sides congruent. And the special things about it are that it has congruent diagonals, and then those base angles are congruent. So the definition of our kite is that it has 2 sets of non-opposite sides congruent, or 2 sets of adjacent sides congruent. And then it has, oh, that should have been pink. Make that pink, not blue. Okay, so that is a theorem. This is a theorem, and those diagonals being perpendicular is a theorem. Okay, so again, if you had a hard time reading that tiny writing, I will scan this and put it online so you can copy it that way. Werner out.